Okay, here again is our fundamental rectangle on the X, Y coordinate axis with our red dot, which is maybe easier to see if I make it a little bigger. Okay. So we should be familiar with this from the preceding video. Now, what I want to do with this is I'm going to transform this graph. Okay, first thing I'm going to do is I'm going to flip this whole picture upside down. So I'm going to flip it down like so, over here, and down here. Okay, so just to keep you on your toes, what is the equation of this line? Y equals what? The equation up here is y equals 4. What's the equation down here? Now you should do a pause if necessary to think that through. Maybe you figured it out, maybe you didn't, but it's y equals -4. Okay, and that should be clear. If we flip the whole thing upside down, it's going to go as far down as it was up. So get the line y equals -4. Now we're flipping the whole thing upside down. So this point up here is going to flip down to here. So I'm going to use, can't necessarily use blue. Actually, no, I'm going to go ahead and use blue. So this point up here becomes this point down here. And this point up here becomes this point down here. Now we're flipping it around the x-axis, so the red dot is going to stay where it is. It's on the x-axis. So when we flip this thing about the x-axis, it's not going to move. Okay, so we could flip several of these points. We could take this point right here, and when we flip it upside down, we're going to get a point. It's directly below the bottom right here. We could flip a whole bunch of points. Matter of fact, we could represent the flipping by drawing arrows up here. This graph. And just flipping those arrows coming down equal distances. And we say that we're probably going to go through points close to these. So now let's go ahead and we can sketch our upside down parabola. Okay, my parabolas are looking better than usual, but don't expect a whole lot from me as far as the accuracy of my pictures. Okay, and if not, I look at it, it's not that great. It's kind of lopsided over here. It's not a good mirror image through the y-axis. Okay, well, anyhow, there it is. Okay, now what I want to do is I want to take this picture and I want to move it so that the red dot goes over, let's say, to move I was going to make isn't going to work well. This thing's going to work a little bit funny. So I'm going to move it a little further than I want to. Okay, so I'm going to move it so that the red dot ends up at x equals 5. That's going to be, that's not my red dot, which is mark. I'll erase it so we don't confuse anything. Okay, so now my red dot is going to go here. Okay, so what's happened is the red dot has been moved five units in this direction. Okay, now actually I kind of overestimated far. I should have been this. We got carried away. Let's say we move it 6 units. Okay, so we can take care of that by letting X equal 6 here. Put the 6 down there for our x-axis. Okay, then we're going to draw this rectangle down here. And okay, we moved over 6. We've also moved up 2 units. Now I draw my rectangle. Now my rectangle goes 2 units this way from the red dot and 2 units this way. So let's see. That's going to put one side of the rectangle here and another side here. And my rectangle, I ended up looking something like this. My scale isn't very good. Rectangles become too wide. That kind of messed up my scale. Probably should have made that 7. I wasn't very careful in marking off my x-axis. You get the idea. Okay, so let's just say this is 6. And then of course this would be 4. And this would be 8. Okay, so 2 units, then 2 units, then 2 units, then 2 units. And not great, but it's not terrible. Okay, now I've got to draw my upside down parabola. And there it is. The shape has been a little distorted. I made that rectangle a little bit too wide, but it's going to look something like this. Okay. So what I just did was I flipped the graph. Put my original square. Fixed units horizontally. And move 2 units vertically. Okay, you should draw your own picture. Okay, if you haven't already. Draw your own picture. Try to scale things a little bit more accurately than I did. And see if you get a better picture than I have. Now, I'm going to use this picture to model the profit of a company. So this curve is going to represent profit. I'm trying to say in there what it is. Profit in when X equals selling price in dollars. Now, why does the curve have this shape? Well, that's a standard model in business, and it's a standard model that occurs quite frequently in applied calculus, which is required, I think, for the business degree. If you sell for too much, nobody's going to buy it. And you're going to lose money because it costs you money to produce this stuff. So here's where you sell, here's where you charge too much, and you're not getting any revenue, you're not getting any profit. And that's not exactly right. You kind of think about it that way. And here's where you have a break-even point where you're not selling it for enough. Okay. You're selling maybe a lot of them, but you're not getting much money for every one you sell. So here you're selling it for too much. You're not selling enough to make up for your expenses. That's more accurate than what I said a minute ago about this point. And here you're not charging enough. You're selling a lot of them, but you're not making enough money, again, to meet your expenses. Now, if this is an accurate model, and of course you've used market research to produce this model, and we're not going to get into how you do market research. Can you see what price you want to charge in order to maximize your profit? And can you see what your maximum profit would be? Now you want to stop and think about that. Okay, so what's the price for maximum profit? What is a maximum profit? In other words, what's the profit when you have that price? Okay, well, hopefully you thought about it, and you should see that the price for maximum profit is $6. Okay. This is your price. Your price goes up, it goes up, it goes up, and you go up to a price between $4 and $5, somewhere between $4 and $5. And now the number you sell is probably going down every time you increase the price, but your price has gone up fast enough that now you break even. Okay. Again, over here, now you're charging too much and you're not breaking even anymore. You're going to start losing. At this point, there's your maximum profit because your profit is your Y. Okay, so the maximum profit looks to be, well, the price for the maximum profit is 6. It's that's for the red dot. Well, in the red dot is at the peak of this parabola, meaning that's your peak price. Now, if we project this point over to the y-axis, we see that, okay, it's a little more than halfway up to 4. I'm going to say y is approximately equal to 2.2. This tells you, according to the model, and this model is your best prediction of what you would have, what you would make at this price. Okay, charge $6, getting enough for every item, and you're still selling enough that your profit beats the profit for any other selling price. Okay, and that your profit is going to be about 2.2. Well, why is the profit in thousands? It's thousands of dollars. I didn't write the dollars. So your profit is $2,200. Okay, so there's an example of how we might use one of these functions in business. And again, this is a standard model. It's one that you really do want to understand, even though I don't expect you to totally understand it from what I've told you here. I'm just trying to demonstrate an important application of these parabolas. These are actually called quadratic functions.